Well, it's really tough to compete with these fantastic images. But I'm going to report a snapshot of the first observations we have of the radiation environment on the surface of another planet, which in itself I think is quite remarkable. Interestingly enough, yesterday was the 100-year anniversary of the discovery of galactic cosmic rays on Earth by Victor Hess with his hot air balloon in eastern Germany. And exactly 100 years later, yesterday, we make the first measurements or characterize the first measurements of galactic cosmic rays and the rest of the radiation spectrum from the surface of Mars. So if we have the next slide, this shows basically zooming in on the top deck of the rover, showing where the rad window is. Radiation Assessment Detector, or rad, field of view is defined for the charged particle channel by this window, and that points towards the zenith. And so we characterize and measure charged particle radiation coming in from the atmosphere, as well as neutral particle radiation, neutrons and gamma rays. And we've learned a lot since in the last 100 years, since the measurements of Victor Hess. We know that, if you'll show the next slide, that the two types of radiation in space, the galactic cosmic rays and solar energetic particles, are driven in a large part by the sun. They go with the solar cycle. And it's actually a very interesting time because the entire nominal mission surface operations will be right around solar maximum. You can see the data in white and the prediction of the solar cycle in red. So we'll have an opportunity to really get a good characterization of both the galactic cosmic ray background, which is what Victor Hess measured 100 years ago, but also the solar energetic particles as they occur in solar particle events as a result of flares or solar storms on the sun. So if you take a look at this profile, this is basically sunspot number as a function of the solar cycle. Galactic cosmic rays vary on an 11-year cycle. Solar energetic particles are episodic. They happen on a scale of hours to days, and they can be very intense. The first measurements we had yesterday, the sun was very quiet in the location of Mars. So the measurements we have are pretty much primarily galactic cosmic rays. But if you show the next slide, this is really just a snapshot of pretty close to the raw data that we observed with rad from the surface. So there's a couple of things to note. This was a 3.5-hour observation with about 1 minute time resolution, or one observation, 1 frame per minute of data storage. And this is really a plot of dose rate in arbitrary units, because we haven't, well, first of all, the mast hadn't been deployed yet, so the mast was partially obstructing our field of view. Secondly, we haven't corrected for the RTG background, nor have we done a correction for the silicon in our plastic detectors. We have 2 different types of detectors on rad. So these are really arbitrary units, but we have put, just for reference, the average dose rate that we observed during cruise. We had a little over 7 months of observations during cruise to characterize rad and get a very good baseline in deep space. And now we are starting to take our measurements on the surface to characterize the radiation environment on the surface. So although this is a quiet time on the surface of Mars, there's really not a large contribution from solar energetic particles. You can see that the spikes in those in that plot are really individual heavy ion hits on the detectors, and it's actually the contribution from these heavy ions that are the biggest effect for biological organisms, whether it be microbial life on Mars or astronauts on future missions to Mars. And so what we will achieve with rad over the next days, months, and years will be to characterize and accumulate the statistics, and also to gather energy spectra of each of these heavy ion events. Basically, we record, as I mentioned, we record the spectra of 26 different charged particles. So we're going to accumulate spectra, energy spectra from each one of these 26 different charged particles, so that we can understand and characterize their contribution to the radiation dose on the surface, as well as the contribution from neutrons. So this is really just a snapshot, but we do see the exciting elements of what we're going to be collecting and accumulating over the next months and years as we continue on with our nominal mission. So stay tuned for future results.